Hello and welcome to today's webinar, Nutraceutical Packaging Tips and Trends for Caps and Sealing. This is Mark Plantier of Enercon Industries, and we're pleased that you have joined us today for what promises to be a very insightful presentation. Please note this webinar is being recorded and will be made available to all registrants as soon as it is posted online, usually within 24 hours. You may ask a question at any time during the webinar by typing it into the question tool provided on your screen. Our panelists will answer questions at the end of the presentation. If there's not time to answer all of the questions, our panelists will follow up with you after the webinar. And as a webinar attendee, you will also be eligible to win an Enercon Yeti tumbler. Winners will be notified tomorrow. Today's presentation will cover trends in the nutraceutical industry, why packagers use induction sealing, principles of cap sealing, pressure, heat, and time, popular closure types used in the nutraceutical industry, how closure types impact sealer and sealing head selection, tips for sealing liquids, powders, and solids, and when to use vented liners, inspection options that can improve your quality control, and at the end, we'll reserve time for questions. We're fortunate today to have two experts who share a passion for induction cap sealing and ensuring packagers always achieve a perfect seal. Owen Schmidt is an industry expert in the field of induction sealing, caps, and containers. He began his packaging career in 2008 with Enercon, where he worked with packagers on optimizing induction sealing operations and troubleshooting application issues. With mold-right plastics, Owen gained extensive experience with closures and jars while providing technical support for end users. In his current position with MJS Packaging, Owen has joined the distribution part of the business as an account executive. Ryan Schilke is Enercon's Vice President of Sales and is an active member of the packaging community for over 20 years. Ryan is a member of PMMI's Global Marketing Committee and former board member of the Association of Sauces and Dressings. Ryan is a frequent industry presenter and has a passion for helping customers achieve a perfect seal. Before I pass it over to Ryan and Owen, I'm going to send out the audience a poll question because these webinars are put together for you, and we want to get a good understanding of why you came today and what you're hoping to learn from today's webinar. So I'm going to launch a poll, and if we get your feedback, we'd really appreciate it. The question is, what are you looking to gain from today's webinar? We have insights on trends in nutraceuticals, information on the latest induction cap sealers, induction sealing troubleshooting information, or just general education. Okay, we've got about half the respondents in. We'll leave it open for a few more seconds. All right, and with that, we'll close the poll down. It looks like most in our audience are here for general education, but there is also a strong contingent of you here for each of the other three topics as well. We appreciate those insights, and with that, we will get on with the presentation as I turn it over to Owen Schmidt.
All right, thank you very much, Mark. It's good to be back in the halls of Enercon presenting with my old friend Ryan Schilke, so really looking forward to this, and thank you all for joining. As far as nutraceutical trends go, this year has been a really interesting year. It's no surprise that immunity supplement sales growth is expected to see a drastic increase of 25% in 2020. Even before COVID-19 hit, the supplements industry was expected to reach a total of $50 billion in sales, which is a staggering figure. A lot of that growth is stemming specifically from the probiotics, anything to do with immune health, boosting for this COVID-19 pandemic. 25% of all consumers now are taking some sort of supplement versus 15% prior to the pandemic. And then this will become more relevant a little bit later in the presentation, but 40% of all these supplements are being purchased online via e-commerce channel. CBD usage has increased for both adults and their pets, interestingly enough, and almost half of the CBD users are purchasing their products online now due to COVID-19.
Some very interesting information Owen, to look at the growth of that, it's pretty amazing to see any industry go from 15% of a population using a product to going to 25% in 1 year. That is absolutely massive. And a lot of what we wanted to talk about today is from a nutraceutical perspective, why you might want to use an induction seal and the benefit it provides to you. And really, those benefits are very similar to what we see across industries. There are obviously components that are unique to the nutraceutical space, and we'll get into those. But in general, we really do a couple of things. One, we're creating a truly hermetic seal. You create that seal when that foil bonds to the container itself. You are preventing oxygen from entering or leaving the container unless you want it to, and we'll talk a little bit more about that down the road. You're going to preserve what's inside your package as well as protect what's outside coming in. So let's talk a little bit about specifically some of those ways that we do this. So the number one reason that induction sealing is what it is today is because the FDA recognized it as a form of tamper evidence. If we go back to the early 80s in the Tylenol tampering that happened in Chicago, the FDA then recognized induction sealing as a form of tamper evidence. That's continued throughout the pharmaceutical space and in many cases is used on the nutraceutical space as well. You provide a induction seal material which welds to the land area of the container. When it's removed, you see foil or other material stuck to the land area of the container, and you can tell that the product has been opened. It instills consumer confidence, all the while providing tamper evidence into your package. I mentioned when we started talking about the hermetic seal that we also preserve freshness by limiting oxygen going into your package. When you seal a package and seal your product, you are basically sealing out any air transmission through the seal there. You actually probably get a little bit more through the plastic container than you would through the foil, but we are able to preserve freshness, extend shelf life of your product, which in the nutraceutical space is also important. This happens to be a nutraceutical customer of ours in Spain who have used an induction seal specifically for that reason. You see the highlight in the quote. They wanted to prevent moisture and oxygen as well as other contaminants from getting in and affecting product quality. And the freshness side is really all about that when we look at nutraceuticals, is how do we preserve the efficacy and the freshness of your products. This is one of my favorite images that we've used over the years. This actually is someone standing on 2 gallons of milk. Obviously, in the nutraceutical space, we're not sealing milk, but in many cases, we are sealing liquids. And the induction seal does create the strength that you can literally stand on a container in many cases and prevent leaks from happening. We don't recommend that that's your test method by any means, but the key part here is that by adding an induction seal to your package, you are going to prevent the possibility of that container leaking, whether it's in the back seat of someone's car as they're transiting at home, or probably more impactfully, I mean, that's obviously the consumer confidence side of things, but in your stream of getting it from your factory to the store shelves, leakage is probably more of a problem when you actually look at that. A leaking container can not only ruin that package, it can ruin the case that it's in, it could ruin the crate that it's on, or it could ruin an entire shipment, let alone potentially other products that might be mixed in with that shipment. This is a great example of a customer who specifically is using an induction seal to prevent leaks, not only, again, from a consumer confidence perspective, but also making sure they don't ruin those packages, the cases, and the pallets that they travel on. Induction seals have become more and more of a recognized means of preventing leakage as e-commerce has expanded and more products are shipping via general package carriers like FedEx and UPS. FedEx, UPS, Amazon all recognize and encourage the use of an induction seal on a liquid product to prevent leakage. In fact, Amazon will go as far as that if you cannot have a double seal on a package, they will package your product in a plastic bag with a zip tie on it, and they will charge you for every one that they need to do. So we talk about the basics of induction sealing. Some of you said 74% want a general education. So this is a really good point for us to talk about. The image on the right shows a good idea of what we're talking about. You've got a plastic container in most cases. You'll have a heat seal layer that's matched to the plastic material of that container. Then you're going to have a layer of foil. The foil is actually what we're coupling our magnetic field that we create in to create heat. And then you've got some sort of backing material, and that can be based on a single piece or two-piece material, which I'll get into a little bit more later. The process itself is a non-contact process. When you screw on the cap, the foil is inserted into the cap at the cap manufacturer. You screw on that cap. It comes in intimate contact with the bottle. Running under the sealer, it actually never touches it. This is probably probably the only piece of packaging equipment, maybe outside of an inkjet printer, that never touches the package on its way through the packaging process.
Absolutely.
So there are three key principles when it comes to induction healing: pressure, heat, and time. This is, again, a great general education piece. You need all three to have a successful package. Oh, and you've got a little bit of experience on this whole part of the process. Can you talk a little bit about the pressure side? How do we get pressure in an induction sealing application?
Absolutely. So application torque is really what it boils down to. The act of screwing on that cap, the threads initiate and applies pressure downward onto the land area of your container. That force is one of the major critical aspects to the induction seal. In my time in the packaging industry, I've spent many days and hours and weeks on packaging lines, and the number one cause for induction seal failure and trouble during the process is inadequate application torque. Those caps need to be screwed on tight so you do get the pressure. I always use the analogy, it's like gluing something to a wall expecting it to stick without holding it in place. It's just not going to happen.
So, and I'm guessing that's when you started working with Enercon here 12 years ago. Wow, long time ago. I'm guessing that was one of the first things you learned that first week of working here, that the number one cause for sealing problems was application torque, or inadequate application torque.
Absolutely. The first couple of days, I spent some time in the lab, and you find out very quickly what happens when you don't have that cap screwed on tightly. You'll get leaks, you'll get flare-ups on the liner. It's very evident when you don't have proper application torque.
So the next piece of the equation, the heat part, is really what we're generating with the induction sealer. We create an electromagnetic field. It's a really big word, but what we're doing, the lines that you see in this picture indicate the field that we're generating. That electromagnetic field couples in with the foil. That's actually why an induction seal has foil, because we need to transfer the heat in some way. That heat generated by the field coupling with the foil generates heat and causes the heat seal layer to start to flow, and that's what bonds with the container. So that is that electromagnetic field is a really key part of this, and it is the reason why this is a non-contact process. The final part of the equation is set by your conveyor speed, and that's time. So the amount of time that a bottle travels under the induction sealer indicates that. And we really don't care if your bottles, you're running 20 bottles per minute, you're running 200 bottles per minute, or 400 bottles per minute. We can configure an induction sealing machine to hit those speeds that you need to achieve. So the timepiece is really just a component that we look in the equation to say, what is the right power supply and sealing head combination that we need for your application? Owen, you want to talk to us a little bit about closure types, and specifically closures that are often used in the nutraceutical space?
Absolutely. It's interesting. The nutraceutical space is changing rapidly on the closure side of things. We are seeing a shift from a standard CT closure, a real generic closure that you just screw on and off, And that shift is happening towards the side of flip tops, more for that consumer convenience side of things. These flip tops are ranging anywhere from your real small ones on the liquids, 22, 24 millimeter, all the way up to 120 millimeter. This particular closure here is for nutraceutical powders, has a built-in scoop retention feature. Again, it's all going back to that consumer experience, ease of use. You can open these with one hand. That shift is rapidly occurring. We are seeing a shift from smaller diameter flip tops to larger diameter flip tops. And it's important to note this just because it does have an implication for your induction sealing process. We'll get into this a little bit later, but that flip top, that change, will change your operating parameters on your production line as well. The next one is the senior-friendly closure. So this is 73 million baby boomers, and they are soon to all be 65 plus by 2030. Nutraceutical use among this population is growing, and as that generation gets older, they will struggle sometimes to open up some of these child-resistant closures, some of these CT closures. So manufacturers have been developing senior-friendly options with these larger ribs on the outside of this container. You do see these on the shelves. If you go to your local CVS or Walgreens, you will see this type of closure. It's gaining in popularity, and it will only increase as this generation of baby boomers gets older in age. With this, I remember specifically a case when I was at EnterCon where this particular closure can trip you up, in that a standard induction sealer set up to run 38 millimeter closures may use a certain tunnel sealing head that is a certain width. But with these added diameter in these ribs, that becomes an extremely tight fit. While it may be a 38 millimeter closure, it's important to note these to your manufacturer of the induction sealer, just so that they can optimize that setup for you. This probably would not run on the same tunnel sealing head as you would a standard 38 millimeter CRC. Then the next shift, this one is relatively new in that the child-resistant closures that have been offered for decades now, they are increasing in size. And the main driver for this is the gummy market on the nutraceutical side of things. Certain formulations for these gummies do require child-resistant packaging, and these larger format CRCs, they allow for easier filling of these gummies. If you can imagine trying to shove large gummies into a 45 millimeter neck finish, it becomes pretty problematic at speeds on a packaging line. So what the fillers are doing is widening that mouth, allowing for the gummies to flow into their container much simpler. And you definitely, there are implications for that, specifically to the induction sealer setup. When you start talking wax melt, the wider that diameter closure, the more difficult it is to get proper wax absorption, to get the two-piece liner to separate properly. So it's these little intricacies that fillers are struggling with on their line. It is important to have those conversations with your supplier so that everything is straightened out before you go to fill these on the line.
All right, now we're going to transition into equipment configuration. We've got some good information on some of the trends when it comes to nutraceutical spaces. There's certainly been a boatload of development from a closure perspective. If I even think back 5 years, I don't know that most of these were on the table 5 years ago. Might have been starting to develop, but there has been a rapid change. And I think that goes along with the numbers you presented earlier, just in the fact of how quickly this market's growing. And there's been some really great innovation that I think this market is driving that we'll see in other markets as well. This will come to food packaging. This will come to other products as well. So
absolutely, yeah, that larger format, the 63, 70 millimeter, 89 millimeter CRCs that have been coming out in recent years, that is the newest development for sure.
So when we talk about an induction sealer, we wanted to talk a little bit about what it consists of. So if you look at the stainless steel, the silver part of the system here. That's what we call our power supply. So we're going to develop a system which will output a certain amount of power, and that's going to depend on the speed that the system is being run at. If we go down from the stainless steel part and look at the black component here on the bottom, that is what we're going to refer to our sealing head. And these are common components. Every induction sealer, whether you're looking at an Enercon or if you're looking at someone else, you happen to have one of our competitors in your facility, all of them are going to have a power supply and sealing head. There are certainly going to be differences in efficiencies in different versions, but every induction sealer you work with will have a power supply and sealing head. The third component that we want to talk a little bit about is inspection options, and we'll dive into that here in a moment. So here you'll see really a pretty broad range of the different induction sealers that you can get with Enercon. On the top left is our handheld Super Seal Junior. This is a great lab environment. Maybe you're trying to scale something up. It's lower production. It has been an industry workhorse for, oh boy, we've probably had the Super Seal Junior for 15 plus years. Before that, it was the Compact Junior. This has been a really, really powerful system. Top right, you're going to see our Super Seal 300, 400, 600 model. That is a new machine that just came out that replaced the industry workhorse in the Super Seal 50, 75, and 100. We've been able to take everything we knew about the 50, 75, and 100 that packagers loved and make some improvements on it that are really, really great improvements that I think you'll find beneficial at a very affordable price point. Lower right shows our Super Seal Touch. This is probably the most innovative induction sealer in the world. We've been able to add features to this machine since it was released. We've got probably 10 or 15 different languages you can run the machine in. You've got recipe control. You've got operator lockout. You've got very intuitive interface from that side of things. So that is really a great option. You handle medium to high-speed applications there. And the bottom left is going to be our Super Seal Max. That is for the really high-speed applications. You can kind of tell from this picture, there's one power supply with two sealing heads. This is really the industry workhorse. When you're talking, a few hundred bottles per minute, that's going to be the machine that you're going to need when you're looking there. So as we look to see which one of those four systems might be right for you, what combination of power supply and sealing heads are right for you, we're really going to look at 3 or 4 things. One, we're going to look at the diameter of your closure. And Owen talked a little bit about it, and it's not always just the diameter of the closure. We want to look at the OD of that as well. If you've got ribs on it, or maybe you've got a closure where the foil has a smaller diameter than the outside of the closure does, we need to look at that. We need to look at the style of closure. Do you have a relatively plain, the blue cap in the back here on the left, that's a standard CT or flat closure? That, the liner is really close to the top. That is a very different experience than you might see in a CRC or some sort of dispensing closure. So the cap style is something we certainly need to be aware of. We're also going to look at liner type. Owen mentioned a little bit about this, about having single piece or 2-piece liners and wax melt. That is another important configuration as we're building a machine and configuring a machine for your application. So cap style, we're going to focus on this a little more and really want to focus on this mustard bottle that's in the middle here. What we are always looking at is how close to the liner can we get with the bottom of the sealing head. And you see in this French's mustard here, you'll see we've got an arrow pointing to where the liner is. That's the bottom arrow there, where the mouse pointer is. Then if we go up to the top arrow, you'll see that's the top of the closure. Well, if we try to use a standard sealing head in that configuration, we're going to be a mile away from where the liner is, and we're not going to be able to heat most efficiently. And for that reason, we've designed a variety of different sealing heads that we're going to share with you right now. Generally speaking, we're going to bucket sealing heads into 3 or 4 categories. On the upper left-hand corner, you'll see that's a picture that we had in this slide earlier. And that is a an example of our wide flat style sealing heads. Those are typically used when you get to a 63 millimeter closure and larger. You'll go 63 all the way up to 120s with those. And the white lines here really illustrate how the heat comes out, how we generate that electromagnetic field. You'll see that it generates from that center line sticker and then radiates out. And that's really what allows us to get that wide range of larger closures as they go through the machine. As we move right across the screen, you'll see this is an example of our tunnel style sealing heads. In these, we're actually generating that field again from the center, but now we're radiating it down over a smaller area. That makes those very efficient in heating and allows us to run pretty high line speeds on those. We're typically going to use a tunnel style head up to a 53 millimeter closure. You know, and if you think about this, generally, if you've got a smaller closure, you've typically probably have a product that is a little bit smaller in size. You're probably filling it faster, and that tunnel design really helps you support running those faster speeds. The bottom left is another example of a tunnel style sealing head, but this time this is more of a specialty. This is what we call a deep tunnel sealing head. We're going to use these in two different cases. One, the example we show here is a smaller diameter closure, probably 18, 20 millimeters, sometime down to a 14 millimeter closure. Here, we need to focus the heat from the sides instead of from the top. So you'll still see we have a center line there, and that center line is important. We'll talk more about that. But now we're generating the heat specifically from the sides. You also would use this in a case like that mustard container that we showed previously, where the liner is quite a ways down. Again, it's more efficient to heat from the sides in that case than it is from the top. The bottom right-hand picture is an example of another wide flat style sealing head, but this time it's our all-in-one. On the next slide, we'll talk a bit more about our all-in-one style sealing heads. So packagers who have a wide range of packages really love our all-in-one sealing heads because it really allows you to seal anywhere from a 20 millimeter closure on up to a 120 with a single sealing head. The caveat with this is that it's probably going to be a flat or a CT cap, maybe one of these larger diameter flips we could use with this, as well as some CRCs. If you have any closures with dispensing, again, like that mustard container, this isn't going to be the right fit. But if you've got that wide range, this is a really, really great option for you. And one of the innovations that we've brought to market is an all-in-one or universal style sealing head with repeatable results. Prior to us bringing out this sealing head, all of the universal heads on the market really had a completely infinite adjustable setup, which was great in that you could dial it in really specifically for your package. Trouble is, when you go back and try and set that up again later, it's really difficult to dial in. So in this case, we've created 4 pivot points in this sealing head. It creates extremely repeatable results, and you can ensure that your operators set it up consistently each and every time. One of our customers in the nutraceutical space had this configuration specifically for that because they want to be able to handle multiple different type of bottles, size bottles, different size closures, and it really is a way to create a universal environment with very minimal changeover when you're changing from one package to another. Owen, can you talk to us a little bit about some considerations we might want to think about for sealing different products and really different products in this nutraceutical space?
Absolutely. Absolutely. So the first one of the major ones is sealing gummies. So in my time on the lines with the fillers trying to troubleshoot issues, I've spent a lot of time on gummy lines in specific. It's forcing packaging change in many cases, like I spoke about earlier with the bottlenecks changing from what used to be filled in a 45 or a 53 millimeter closure going to the 63 or the 70 millimeter CRC closures. And that really, it does lead to some possible wax melt issues. A lot of these closures use what's called a two-piece liner, where you have a pulp backing bonded with a wax to the foil, and you have to get that wax to properly separate in order to be able to unscrew the closure without tearing the liner, or just not being able to get the closure off if it's significant enough. So it's nothing that we can't overcome. It's a matter of making sure that you do your homework on the front end to make sure the sealer is set up to optimized for that change. Ryan alluded to the sealing head choice, going up to a 53 millimeter closure size on a tunnel style sealing head. That works until you go to a 63, at which point the sealer configuration changes, and there are some intricacies that you need to pay attention to. You can feel free to give either of us a call. We can walk through that with you if that's something that you are struggling with. Also with the gummies, one thing that I do see on the line is that the gummies, because they don't want to tumble into the jar very easily, it is needed to vibrate these gummies down. You can either tamp them down or vibrate them, just to make sure that there is head space between the liner and the product. The last thing you want, we call it a heat sink. The last thing you want is product in contact with that liner when we're trying to heat it up. It will draw heat away from that liner. It will melt your gummies. You'll have gummies stuck to your liner. If you ever do open your cap and there's a gummy stuck to that liner, the gummy came into contact with that liner while it was still hot, either during the induction sealing process, or some packagers would pick that up, tip the bottle over, or check the seal and it's still warm. So that is something to look at. And then we'll talk a little bit more about this later, but certain formulations, I'm by no means a chemist, but certain formulations of these gummies do require venting, and we'll talk about that in just a bit. As far as sealing tablets and capsules go, this is, Ryan mentioned it earlier, 1982 Tylenol tampering incident. This is what induction sealing was originally designed for. It is the most standard application that you can get. Again, it goes back to pressure, heat, and time. We can't speak to this enough. PHT, it is the three critical aspects that you need to achieve a perfect seal. And you want to ensure consistency across the board with that pressure, with that heat, and with that time. So maintaining consistency is critical here. As far as sealing liquids go, ensure the product isn't overfilled. If you do overfill, again, that product could come into contact as the bottle's moving down the line. It's sloshing up against the liner, can draw heat away from that, causing a leak because the liner just didn't get as hot as the other liners. And then, does your product need a vent? Specific to the nutraceutical industry, there's a couple products that I'll speak about in just a bit that would require a vent. And then liner selection is critical for this. Lots of nutraceutical products are packaged in a universal liner, more so on the dry product side of things. But when you start talking liquids, a lot of these nutraceutical liquids do have some sort of oil content to them, and oils are not friendly to universal liners, so it's really important to pay attention to that in your liner selection for your packaging. And then sealing powdered products. So lots of your nutraceuticals are powders. Clean land area is critical for this. So I've seen all sorts of different configurations on packaging lines, from vacuums trying to suck product off the land area to blowers, but that lots of times will introduce a lot more content into the air, and it will naturally settle down places as well. I've seen static elimination units get placed on the line just to try to keep that product from getting drawn to the plastic bottle as it's traveling down the production line. And then some of these are produced in hazardous environments. It's important. Lots of people will run these jars outside of the actual filling room through a hole in the wall or something to that effect, and then seal on the outside. One, it helps with the induction sealer itself, just from the longevity, increased airflow. You don't have excessive buildup of the powdered products on your sealing heads, in your power supply, that sort of thing. And then it just makes for a cleaner environment to get that seal. And then on the vented side of things, so this is important for the nutraceutical side of things. Vented liners still prevent paneling, they prevent leaks, and prevent contamination. You can get vented liners for both dry products and liquid products. And we'll speak a little bit here. The heat and temperature must be dialed in to ensure that the vent performance maintains the airflow that is needed to properly vent. This is more specific to the liquid side of things. If you look in the bottom right-hand corner on the liquid products, that backer and that membrane, it's a mesh membrane that's woven together to various different pore sizes. So you can, depending on your product and the needs for that vent, while balancing the product viscosity needs to, you can't have it get through those pores, but you still need proper airflow. So there's a balance. It's really important to work with your supplier, that we can get in touch with the venting companies to choose the proper vent for that specific product. There's a bunch of different membranes that you can use depending on the makeup of your product, whether or not it's oil-based or water-based, and then what pore size would be needed. But as you heat up that vent, if you overheat those liners, they can stretch the vent and it compromises it. So it's really important to dial in that heat. I always say Tim Taylor syndrome from the old Tool Time show. More power is not always your friend, specifically in this case with the vented liners. You do not want that vent overheated, and a lot of the venting suppliers, when they're punching these vents into the liners and installing them, they'll try to move that vent as far away from the outer diameter of that liner as possible, and that's where your heat is most extreme, on the outer side, because we heat from the outside in. So moving that vent towards the center of the liner will expose it to less heat during the process and give you a better chance for success. And then on the dry product side of things, if you look over here, you still have your heat seal layer, and then there's a paper layer. So when you look at the bottom of these liners, a traditional induction seal, you look at the liner and you see foil on the bottom because that heat seal layer is clear, and you'll see the foil. With a dry product vented liner, you will actually see a white bottom layer. You see there's a heat seal layer that's clear, then there's a layer of paper, and the product, or the bottle actually vents through that paper layer before it gets to the foil, and then you have a backing material on top of that. You can control the amount of venting with that paper layer thickness. So you could go to a half 5 mil paper or a 7 mil paper. The thicker the paper, the more that product will vent. These are very popular in the nutraceutical space. Again, on the venting side of things, it's really important to not overheat it, and you should be good to go. But the dry product vents also, it can become extreme, especially when you're talking about gummies. Some of these formulations, I have seen it where the closures, as you're unscrewing them, there's enough pressure built up inside of that bottle that the cap will actually fly off as you're unscrewing it, and it could fly across the room. I have seen it happen. I didn't believe it until I saw it, but the pressure buildup inside of these packages, because of the product formulation, can become extreme. And also, on the vented side of things for liquids, it's more so a paneling issue. You'll have certain products such as your essential oils, fish oils. Those types of products will scavenge the oxygen from within the package, and that will create those sidewalls paneling in, sucking in. You'll get a product that does not look good on the shelf. It looks like somebody has stepped on it or squeezed it, tampered with it. It can create issues with the labeling, and it's just not as aesthetically pleasing. You still have, the good news is, if your bottle's paneling, your induction seal has done its job because it's not allowing oxygen to exchange between the inside of that package and the atmosphere. The bad news is it does tend to suck in those sidewalls. You could go with a vented liner, or you could go with a much heavier gram weight bottle. There are some costs associated with both, but a vented liner typically is less expensive than going with an extremely heavyweight bottle to deal with that paneling issue.
All right. Thanks, Owen, and thanks, Ryan. We're going to shift gears here in our next section. We're going to talk about tips for achieving a perfect seal. And we know that at least half of you specifically indicated you are looking for some induction sealing troubleshooting tips. So we're going to open up a second poll here. It's what is your number one sealing issue? I'm going to launch that poll now. Options include inconsistent seals, uneven heating, improper wax separation, and leaking seals. So we'll give you a little bit of time here to respond to that. We're going to touch upon all these topics, but we want to make sure that if there's one that seems to be more important to our audience, we'll spend a little more time on it. Looks like we got about a third of the vote in.
Mark, kind of like election day, a third of the votes in?
A third of the vote is already in. We had mail-in ballots. All right, we'll leave this open for a little bit, but the two clear leaders right now are inconsistent seals and leaking seals. So with that, we'll close up the poll, and we'll move on where Ryan will talk about ways to ensure you will achieve a perfect seal.
Thanks, Mark. And yeah, knowing that folks are looking at inconsistent seals and leaking seals, probably, seeing some similar problems from a setup perspective. So I think some of the things we'll talk about here today will certainly go into how you can achieve a perfect seal. And a lot of it really is, Owen, setup. It really is setup, both setup of the induction sealer, and as you mentioned earlier, it's application torque setup as well.
Yeah, it's really interesting. So the inconsistent seals, drawing a distinction between that and leaking seals, there's definitely some crossover there. But when you start talking inconsistencies to me says some of them are sealing, some of them aren't sealing, some of them are reacting differently. And that really leads to the setup side of things, whether it's application torque, whether it's alignment, which you'll talk about here. The leaking seals, it could be a setup. It could be that one isn't sealing, the rest of them are. But if it's leaking, then we start looking at if all of them are leaking, your package, your bottle cap interaction, your liner choice, that sort of thing.
Okay. So some of the things that you're going to want to look at, and we've got an entire webinar dedicated to this with Achieve a Perfect Seal. So if you want to dive into this more, we certainly have that out there. And Mark, I think we could probably include a link in the follow-up email for Achieve a Perfect Seal. It's recorded on the website as well. So you're going to want to, when you're setting up the machine, there's really two things that you want to make sure you do correctly and consistently each and every time. One of it is if we look at the picture on the left here at the end view, we talked about the center line. I pointed out the center line as we were talking about sealing heads. And you want to make sure that every bottle, the center of that bottle is traveling down the center of the machine. That's why on all of our sealing heads, we've got a center line sticker there. And you want to make sure you set up initially that when the head is in the correct position, it goes down the center. There's a little caveat there if you work with some of the all-in-one sealing heads, but getting it to go down the center is absolutely important. If you're steering off from one side to the other, you'll get more heat on one side than the other, often leading to an inconsistent seal from that side as well. The other part that you want to do is you want to make sure that there's the correct gap between the top of the cap and the bottom of the sealing head. So every machine we sell comes with a 1/8 inch thick ruler. The 1/8 inch isn't necessarily important. It is where we feel like you get the best performance out of the machine. But if it's an 1/8 inch or if it's a 1/4 inch, it doesn't really matter as long as you are consistent in your setup. Take a bottle, set one on one end, set one on the other, put that ruler on top of the caps, and lower the machine down into position. That will, when you start to feel, you give a little tug on that ruler. When it just starts to have a little bit of friction, that's where it's there. It's like a feeler gauge, and that's really what you're trying to do. So again, we ship those with every system. If you need one, if you don't have one, or if you say, hey, I need a dozen of these, shoot me an email. I'll make sure we get some out to you. It's something we do for our customers all the time. And even if you're not a customer, we're happy to send them with you. And I think Owen probably travels with them every once in a while too.
You bet.
So the other key piece to this is once you make sure that you've got your sealing head set up correctly, both from a gap and from a centering perspective, now what we want to do is establish a sealing window. And Owen talked about how important this was when dealing with the vented seal to make sure that you're not overheating that seal. So what you're going to do is you're really going to start at a point set your conveyor at the speed it's going to run at, and go ahead and run a bottle through. This can be an empty bottle, doesn't need to have product in it, unless your product has some temperature differences. Maybe it's filled at a cold temperature or a very high temperature, but usually you can use an empty bottle to get this started. Run it through. Say set the machine at 50%. If you don't get a seal, kick it up by 5%. If you still don't get a seal, kick it up by another 5%. Essentially work your way up to the point where you start to get a seal, and then move in 1 or 2% increments and find out, all right, where do I start to get a seal? And then again, start going up in 5% increments past the point where you get a good seal to where it begins to overheat. Overheating is often indicated by wrinkling on the back of the material, or if it's a two-piece liner. It's a pretty extreme example there, but that is some burning in the pulpboard back in the cap. So either wrinkling or burning is what you're going to see, and oftentimes you can smell it as well. You can smell burnt plastic. Once you find that top end, what you're then going to do is you're going to find the point where you start to get a good seal and start to burn, and you're going to find some point in the middle there. And this is another way of looking at that, right? You've got no seal to overheated, good. You find yourself, you pick a point in the middle, and that's really what's going to help you make sure that you're within your operating window. We recommend that you go through this every time. We recommend that you record it in your initial setup, go back to those notes, and when you set up the line to run again for that product, go through the process again. It doesn't take, and if you've recorded it, found it once, how long does it take to go through a second time?
Not long at all.
Pretty
Not long at all. A couple minutes, you'll be set to go, and it's really a matter of consistency with induction sealing, making sure that your belt speed is going the exact same as it was last time you ran, your application torques are dialed in and proper, and your sealer's set to that optimal level.
So you affect the quality of your product by setting the operating window, setting up the sealer, making sure you've got the right application torque. But there's also a component of quality control that we want to talk a little bit about, and our friends down at Best Formulations use this specifically in their application to make sure that we get all of the bottles that are coming through with proper seals. So you can integrate quality control features into the sealer itself. You can also do some of these within the capper itself. And some of the things that we're going to look at is we're going to look at, number one, are bottles traveling into the sealer and out of the sealer and not getting stuck in between? On all of our production systems, we've got the ability to ensure that bottles that enter the sealer exit and that they don't get stuck and overheat. The last thing you want to do is send out a bottle that has a plastic smell to it. Your customers really don't want their product smelling like burnt plastic on that side of things. We're also going to check for the presence of foil. Now, Owen, you can probably talk a little bit about some of the quality controls that cap manufacturers have in place to ensure that caps leave their places with closures, but you still do run a chance of liner falling out either in the box in shipment or when they get thrown in the hopper.
Yeah, absolutely. So if you're dealing with a quality manufacturer, those liner manufacturers or closure manufacturers will have vision systems on their production lines in the lining department. They should be looking for broken caps, half moon seals where the overlap was too close and cut off some of the seal. You'll be looking for things like that, presence of foil. But this is a great secondary inspection to ensure that in transit, if one of those liners, particularly in a single piece liner application where those liners, you can see them start to curl up if it's high humidity environment, the larger the diameter of the closure, the more likely that is to happen, that sort of thing. But this is a great secondary inspection to ensure, because it is a blind non-contact process, you're just going to screw that cap on and you cannot see whether or not that liner's there. So this is a great way to further protect yourself on the packaging line.
Yes, obviously, if there's not a foil in the closure, you're not going to create an induction seal. One of the other ways that you can struggle to get an induction seal is if the cap is not applied properly, if it's cocked, crooked, however you want to describe it. If that liner is not in intimate contact with the land area of the container, you won't get a seal. We're able to detect for that as well. in both of those cases, we're going to reject those bottles off the line, whether with the rejection system that we provide or a third-party rejection system. You certainly want to remove those off the line to increase your chances that a consumer doesn't get a package that doesn't have a seal.
All right. Thanks, Ryan. Thanks, Owen. So just to wrap up a couple of the highlights here, nutraceuticals are certainly growing at a rapid rate, and packaging is a big part of that. Induction sealing is known to prevent leaks, preserve freshness, and provide tamper evidence. The key variables to make sure you have consistency with to achieve a perfect seal include pressure, heat, and time. We looked at different cap styles, flip top, CRC, senior, large format caps as well being used in the nutraceutical industry, and how those cap geometries and liner sizes and position relative to the top of the cap can dictate the required induction sealer and setup. We talked about differences in sealing liquids and powders. We looked at setting up an operating window for each of your applications. And again, on the Enercon website, you can find a whole webinar just dedicated to that topic, walking you through step by step. And inspection options and how they can add quality control to your operation. We're going to get to your questions. We're going to throw one more poll question your way. I'm going to activate that now. And while I launch that, also feel free to use the question tool to submit your questions. And we'll begin answering those as soon as we close the poll up. All right, we'll leave that poll open for a few more seconds here. Looks like we got a number of questions already in the hopper. And we'll go ahead and we will close that poll. We'll also put up on the screen Owen and Ryan's contact information if you want to get a hold of them directly. Can you induction seal 5,000 bottles an hour?
Absolutely. I just pulled out my calculator. That equates to roughly 83 bottles per minute, which is right in the wheelhouse. That is no problem whatsoever. You just need to make sure that your sealer is capable of handling it. And to Ryan's point earlier in the presentation, it doesn't necessarily matter how many bottles per minute that your production rate is. It matters how fast that conveyor belt is traveling. So if you get yourself a digital tachometer, it's a packager's best friend to really tell how fast that belt is traveling. It takes 2 seconds to confirm that, and then with that information, you can optimize the sealer to make sure that you're covered. But 83 bottles per minute is no problem. We run applications, we see them upwards of, I've been on a line that's doing 500 bottles per minute. So
and that really depends on the size package that you're packaging as well. I mean, if you're filling a gallon-sized container versus a 500 ml bottle, very different filling speeds. So it's one of the things to think about as you think about if you can fill it at that rate, you can generally induction seal it at that same rate.
Correct.
This person is asking, we have a wash-off area between where our caps are screwed on and our sealer. Will water on top of the cap affect the seal quality?
So I'm guessing what they're doing here is they're probably spraying the bottle down after filling, before labeling, but before sealing. If you have got the cap screwed on properly and it's, what would you say, Owen? If it's a light spray, you probably don't have an issue. The water on top of the cap's not going to be an issue. You just have to make sure you've got the application torque there to ensure that you're not getting any water inside the package.
Correct. Yeah, with the electromagnetic field will see right through that water. It is only heating up the foil, and the foil should be protected by the closure itself, so that should not be an issue.
Okay, and when it comes to application torque, how do you determine the optimal torque for caps for the best seal?
In general, the rule of thumb is half the closure's diameter in inch-pounds of application torque. Now, the trouble is on a real-time packaging line, it's very difficult to, lots of folks are using inline spindle cappers. It's very difficult to control that torque and really dial it in to give you a proper readout. So what you need to do is measure the removal torque after your capper, measure that removal torque and correlate that with when you screw your closure on to half the cap's diameter. For a 38 millimeter closure, let's use 18 inch-pounds of application torque. So hand tighten 1 to 18 inch-pounds of application torque, remove it, record those data points, and then compare those to what you're getting coming off of your capper prior to your induction sealer. So once it goes through the induction sealer, removal torques, they're only used more for FDA compliance with ensuring that the CRC functionality is still there. Once you come through the induction sealer, your cap could loosen up. It could tighten depending on the backing materials. So you can forget about those numbers. You want to check those removal torques after your cap or prior to induction sealing to make sure consistent values are achieved.
And Owen, that was the follow-up question, the best way to test that torque application afterwards.
Yeah, there's all sorts of different machines and equipment out there that you can purchase. I traveled around with a little handheld torque meter that you could screw a bottle into and unscrew it, and it would give you a inch-pound removal torque value, and you can also just screw the closures on and get that application torque value. They are very handy. Lots of packagers and fillers are using them on the line and using that as a good quality control check. They'll come around every 30 minutes, every hour, take a sample set of 10 to 20 bottles and measure those values, record them so that you can go back in your logs if you did have an issue to see if your capper was not applying the proper torques at any point during that production run.
Okay, here's a question on why is the liner foil across the entire area of the cap? Couldn't you just seal around the bottle lip with a ring of foil?
So this really goes into how the liner material is manufactured, and you've got to step back a few steps here. While what as packagers we see it as it's a round disc. Why don't we just make it a ring? It's a great idea and a good concept. But all of this material is made on commercial converting equipment that essentially makes it in, say 60-inch wide webs, and you're either laminating or extruding different materials together so that is in a certain width form that it comes from the manufacturer of the foil material. Then it goes to cap suppliers. And Owen, I think you can talk to this, is cap suppliers buy it in slit widths that run on their capping machines. So essentially, if you were to take the foil out of the middle, you kind of be throwing it away. There's no real good way to do that based on having to punch those sizes.
Correct. Yeah, because they're ordered in jumbo rolls and then slit down per the lining machine that it's going to be run on and then punched out for the specific diameter. There's no good way. It's more of a processing issue on the liner and lining application side of things that just doesn't make it practical. And there's also some differences in the way that the electromagnetic field reacts if you don't have a solid surface foil all the way across there. So it gets into some pretty deep engineering and physics related topics, but
and neither of us were good at physics in college, were we?
Correct. That's why I sold induction cap sealers and now bottles and caps. So,
what is the best way to seal containers when the product foams over the top and maybe in the sealing area?
So if your product is foaming, the foam in and of itself shouldn't be that tricky to seal through. You can seal through liquids. Again, it gets to the consistency side of things. So if it's foaming, that will create potentially a heat sink if that foam is in contact with your liner when you're trying to seal it. Now, if all of the bottles experience that same effect, you can dial in your processing window to compensate for that. We sealed gallons of milk, and multiple times they use a flood filling and it's overflowing, and you have milk in contact with it. Well, as long as it's consistently in contact with it, you can just turn up your power to compensate for that heat sink. The problem would be if you're going to overheat it, then say you set some bottles aside and that foam dissipates and then you run it through the sealer later where that's no longer in contact. You could you just want to watch for something like that. But the foam in and of itself, you should be able to seal right through that. The pressure that you apply with the torque on the closure is going to dissipate any of that foam that's in between the liner and the land area where you need to seal.
Yeah, the foam's probably not as much of a concern as a heat sink as it would be actual product touching the
Correct.
liner.
Correct.
All right, we have 2 questions related to sealing glass containers with liquid products or even oily products.
So, I mean, glass is always a tricky one. We have some very successful glass applications. The key there is the treatment that the glass has coming from the manufacturer. The liner manufacturers themselves have materials that work on glass. You know, when I think about dry products that we seal in glass, there's quite a few of them on that side.
Yep.
And I've seen some successful applications with oily products in lining and induction sealing. When you get to more water-based products, it gets a little trickier.
Yep, there are some new products out there. I recall a presentation not too long ago, just a few weeks ago. There's some new product coming in from Europe, I believe, that is supposed to help compensate with that trouble, that historic problem. It's been the holy grail for induction sealing since I've been in the industry, is how to get a proper seal for liquids in glass. People have tried it, people have struggled, and people have failed. So it really depends on what that product is, the glass treatment that Ryan mentioned, as well as the lining material. And there are some new developments. I'd be happy to speak with you more. I just need to get some more information myself on that particular product, and we can talk to you further about it.
I've got a question here on how does the product traveling on rollers after the seal affect the seal rather than a conveyor? So on a roller instead of a conveyor.
I think the key there is going to be whether you're on a roller or a conveyor. It really doesn't make a difference if you've got the same piece. You've got to make sure that the container is traveling down at a consistent height. It's not bobbing up and down. And that would be my only concern from a roller perspective.
My concern would be on the speed consistency of it. How are those rollers? If it's just a gravity-fed roller, you can line up your induction sealer as long as those speeds are consistent. But if your bearings are starting to go and those rollers aren't rolling as fast as they used to roll, that sort of thing, you could run into some potential issues. I have not personally seen rollers underneath the induction sealers before. Most people would be better off just purchasing a 6-foot section of conveyor, setting it up there just to eliminate that potential for variable speeds coming underneath the sealer. And then again, the chatter, the bottles vibrating up and down, a conveyor is going to be a much smoother process for that.
And you've got that potential issue with the bottle chatter on a conveyor. You want to make sure that whether you're using rollers or a conveyor, that bottle's smoothly going through and not chattering up and down at all.
Correct.
All right, looks like we've got time for just a couple more questions here. What would be the main cause of pinholes around the edge of a seal?
Overheating. So pinholes are very difficult to see with the naked eye, but they certainly do exist. And what happens is if you overheat that liner, that heat seal layer will develop small little pinholes, and that allows product access to the foil. If you have any sort of aggressive products in there, any vinegars, anything like that, that can become problematic. And just overall separation. If the product's got access to the foil, it's also got access to the bonding agent between those two layers and can potentially cause some leakage. So it's a matter of dialing in that heat. And if you have pinholing, you have an operating window. Typically depending on the application, but say 10 percentage points on your induction sealer would be a good processing window. If you find yourself operating on the high end of that, try backing off and operate on the lower end. Just because it's on the lower end doesn't mean you're going to get any different performance on the induction sealing side of things. It's just going to mean that you have more wiggle room on the upper end to compensate for some of that pinholing.
All right, and one final question. How does the temperature of a liquid product, or does the temperature of a liquid product affect the sealing power needed to get a good seal?
Oh, it certainly does. Owen mentioned sealing milk, and it brought back memories of standing in a dairy facility in about 35, 40 degree temperatures, watching line trials, and it absolutely impacts it. If you're filling something at room temperature and it runs down, and say for some reason you change products and then go to a cold fill, if it is the exact same package running the exact same speed, you are in all likelihood going to need more power to seal a cold fill product than you would at something at room temperature. The opposite pertains if you're hot filling something. If you're filling at, say, 180 degrees Fahrenheit, it's probably going to take less power out of the induction sealer to seal that than it is something at a room temperature.
Yeah, what it boils down to is that foil has to get to its critical temperature to melt that heat seal layer that's designed to bond to your bottle. So if it's starting out at a higher temperature, you're going to need less heat in order to reach that optimal level. If it's starting out at a colder temperature, you're going to need more heat to get up to there. So you're starting at different points depending on the filling temperature of the product. If you are filling hot fill, it is important, just as a side note, to make sure you give that liner plenty of time to cool off before you do try to test that induction seal. That heat seal layer will still be softened, and it needs time to set up or solidify in order to truly test that seal.
All right. Thank you, Owen. Thank you, Ryan. Thanks to MJS Packaging for partnering with us today on the webinar. And thanks to our audience for joining us. Again, this webinar was recorded. You'll be receiving a link to access the presentation and recording when it's posted online, usually within 24 hours. In the meantime, if you have any additional questions, please feel free to reach out to Owen and Ryan. If you have ideas for other webinars, let us know. And shoot us a line and let us know what you thought of this webinar. We appreciate your feedback, and we'll look forward to seeing you at the next webinar. That will conclude today's webinar. Have a great rest of your day.